Okay, here we go. So you said 2, 11, 14, 15, and one other one. So let's look at 2 first. And you can see the answers there in red. So it says triangle 3, 4, 5. All right, they're trying to trick you here. You just have to understand, those special numbers. 3, 4, 5 is one of those Pythagorean triples, right? So how are you supposed to know that just from the sides? Well, by now you should always be ready to see if you ever have a triangle with side lengths 3, 4, 5, it's a right triangle. So 3, 4, 5. So it's a right triangle. So let's see, base times height divided by 2 because we're doing area. So that's 3 times 4, which is 12, divided by 2 is 6. So that gives you 6, and there's no units there, so 6 square units. So that's number 2. Let's see, number 11. So it's an isosceles triangle with isosceles right triangle with a hypotenuse of 8. Okay, so, well, if it's an isosceles triangle, that means 2 of the sides are the same. And since the hypotenuse is 8 and it's the longest side, then that means the other 2 sides are x. I could use Pythagorean theorem. Remember, we're trying to do area, so I need base times height. So that's x times x divided by 2. So I just need to find out what x is. So I could use Pythagorean theorem. That'd be the easiest one. So let's see, a squared plus b squared. So x squared plus x squared equals 8 squared. So that's 2x squared is equal to 64. Divide both sides by 2. Take the square root of 32. Let's see, 16 times 2 is 32, and the square root of 16 is 4, so we have 4 root 2. So that means x is 4 root 2, and if you notice the triangle there in blue, base and height would both be 4 root 2. So it would be 4 root 2 times 4 root 2 divided by 2. So on the square roots, remember, for square roots, you do outside with outsides, inside with insides. So 4 times 4 is 16. 2 times 2 is 4. The square root of 4 is 2. The 2's would cancel, or if you prefer, 2 times 16 is 32. 32 divided by 2 is 16. Either way works. Okay, so that was all the way up through 11. So now let's do 14, 15. So 14, rhombus. Remember, that's quadrilateral, all sides equal, and it says the sides are 6 centimeters, and it says with an angle of 120. Well, a rhombus, unless it's a square, is going to have 2 obtuse angles and 2 acute angles. And so 120 is obtuse, and well, we know something about rhombi opposite or angles that are opposite each other are the same, congruent. So that would make that 120. And the other 2 are going to be the same values. Let's see, 120 plus 120 is 240. Subtract that from 360, leaves 120, but it's got to be divided by 2. In other words, that angle's 60 and that angle's 60. All right, making some progress here. We think about the formula for area of a rhombus as the 2 diagonals multiplied together divided by 2. So diagonal 1 times diagonal 2 divided by 2. So if we figure out those red dotted lines there, multiply them together, divide by 2, you can probably see where I'm going with this. It would be pretty easy. Now, we know for a rhombus, the diagonals bisect each other. And it would be pretty easy to see with using some vertical angles there that all of those triangles, the 2 triangles that are opposite each other, they're congruent to each other. So if those 2 triangles are congruent to each other, then I can draw one of those triangles. I'll just draw one of those. Well, half of 60 is 30, so that's a 30, 60, 90 triangle as well, too. And we know that for a 30, 60, 90 triangle, well, let's see. We already know that that side is 6. I'm just getting that from the, let me draw this for you, if I can. I'm losing my drawing tool here. There it goes. So what am I looking at? I'm looking at this triangle right here, okay? So we know that this side corresponds to this side right here. This side right here, okay? And that's 6. And so we know that this angle right here is 30. And the side opposite 30 is A. And the hypotenuse is equal to 2A. And the long leg is equal to A root 3. So let's see. If 2A is equal to 6, that means A is 3. So that means this value right here is 3. Where's that? That is right. Let me go through all those numbers there. 3 root 3. So that's 3. I'm going to erase some stuff here. It's kind of in the way. Erase. So that's 3. And remember, diagonals bisect each other, so the other side is 3, and then the other two sides would be 3 root 3. Remember, the long leg is equal to a root 3. Let me erase all this mess here. There we go. That's more. All right, now what? Now we got to multiply the two diagonals together and divide by 2. Well, one of the diagonals is 3 plus 3. That would be 6. And the other one is 3 root 3 plus 3 root 3. 3 root 3 plus 3 root 3 is 6 root 3. 6 times 6 is 36, and half of 36 is 18. So we get this ugly answer, but that's the answer. I'm not sure why my square root bar didn't go all the way across. All right, so that is answer number 14. All right, answer number 15. It says we got it. Well, this is the same as the previous problem, 30, 60, 90, except the hypotenuse now is 10. Remember, the hypotenuse on a 30, 60, 90 triangle is 2a. So that means if 2a is equal to 10, then a is equal to 5, and 5 is the angle opposite the 30 degree. And then the other side, do we need the other side? Yeah, we do, because we're trying to do area of the triangle, so we need base times height. And so let's see, the other side would be a root 3, so it would be 5 root 3. Then we simply need to multiply base times height. So 5 times 5 root 3, all divided by 2. So 25 root 3 over 2. Not a pleasant answer, but that's the answer. All right, last question. We have a parallelogram. It tells us, I cut out that portion of it, but it says it's a parallelogram. It says PQRS is a parallelogram right there. So it says find the area of parallelogram PQRS. Well, the formula for parallelogram is base times height. Well, it's literally those values are given. The base is 30 and the height is what? 16. So it's 30 times 16, which is 480. That's part A. Part B says, let's see, what does it say? It says triangle PSR. So where is triangle PSR? So triangle PSR, let's see, P to S. I should have done that in blue. Let me do that again. Erase that red, make it blue. All right, P to S to R. So this triangle right here. Well, I can clearly see that the base is 30 and well, the height is 16. All right, so that wasn't too bad. And then we got divided by 2. So, well, we already did that. 30 times 16 is 480. So half of 480 is 240. And then let's see the last portion. Let me erase all that. The last portion is, let's see, OSR. So where is OSR? I've already shown you the answer here. OSR, O to S to R. Well, clearly I got a base of 30. So what's the height, right? Well, we know that O sits smack dab in the middle of the parallelogram. In other words, it's going to be half of the entire height. And if the height is 16, then half of that height for triangle OSR would be 8. So that would be 30 times 8 divided by 2, or 4 times 30, which is 120. And there you go. There are all of the answers you requested. If that didn't make sense, send me another email and I'll help you out some more.